Hello everyone, welcome back to our YouTube channel. I'm Srikanth Reddy and today we're back with another contest where we dive into CodeForces Round 946. Let's get straight to the questions, starting with question A. Okay, let's look at the problem statement. Little Rosie has a phone with a desktop and the desktop can consist of several screens. Each screen is represented as a grid of size 5 rows 3. That is 5 rows and 3 columns. Okay. And there are X applications with an icon size of 1 cross 1 cells. Such an icon occupies only one cell of the screen. There are also Y applications with an icon size of 2 cross 2 cells. Such an icon occupies a square of 4 cells on the screen. Okay. Each cell of each screen can be occupied by no more than one icon. Okay. Rosie wants to place the application icons on the minimum number of screens. Help her find the minimum number of screens needed. Okay. The input format, as usual, the number of test cases, and inside each and every test case, we are supposed to read two integers x and y, where x represents the number of x applications, y represents the number of y applications. And of course, x application having 1 cross 1 icon and y application having corresponding 2 cross 2 icon. Okay, let me just explain the problem statement along with sampler. So first we'll consider a screen having the dimensions 5 cross 3, right? So we'll just draw the 5 cross 3 screen. So 5 rows and 3 columns. Now, we'll consider the first example. First, we'll copy this. Okay. The first example is x equal to 1, y equal to 1. Now, first I'll consider 1 cross 1 cell, which is for x application. Okay, let me just randomly consider it over here. Let me just use purple for that. Okay, cool. Now, the remaining is for y equal to 1. So, I should occupy 2 cross 2 cells, as in 4 square cells, right? So, I'll say this. But is it valid if I consider it this way? No. What's the reason? The reason is each cell of each screen can be occupied by no more than one icon. For that reason, I should not consider it this way. I should consider first x equal to 1 this way and y equal to 1 somewhere the cell location excluding x equal to 1. So let's say I'm going to place it this way. Okay. In one screen, I'm able to fix all my x and y. So I can simply print 1 as my answer. Okay. For this example, 1 is the answer. I hope you understood. Now we'll go to another example, which is 7 comma 2. 7 comma 2 is just a small replication with this diagram. I'm just writing it over here. 7 comma 2, right? Here anyhow we placed 1, 2, 3, 4, 5, 6, 7. I'm just arranging it randomly in my 5 cross matrix. Okay. Now, what's my answer? Even for 7 comma 2, I'm able to do this in one screen. So again, 1 is my answer. Okay, is that clear? 1 is my answer. Now, here comes the interesting point. 12 comma 4. 12 comma 4. So you should arrange them in such a way that at the end, what's your ultimate motive? You should find the minimum number of screens needed. Okay? Just pause the video, put your thoughts on the paper, try out some logic, and start writing the code. And of course, don't submit. Check whether you are missing any edge cases, etc., etc. And then submit the code. You're good to go. Okay. Yeah. Now we can resume the explanation part. So what about the answer for 12 comma 4? What about the answer for 12 comma 4? So how will you consider the screens first? How will you consider the screens? First, let us consider one screen here and another screen here. For x equal to 12 and y equal to 4, x equal to 12 and y equal to 4, right? Now, I'll just place one y out of these 4 applications. So let me just place it over here. 1, 2, 3, 4. Okay, 4 cells occupied. Now, where else I can place? I can the next or here. Now, till now, remaining to nowhere. Now, here is exactly another screen. This is for the third. This is for the we are done with. What next? We have to two available. First, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is how you're supposed to make the arrangements. Okay, so I can guess the most of you people might have missed the edge case it in this way, something like 8 comma 0 or maybe 90 comma 0 this way. So you have to handle these edge cases appropriately. Okay, okay. Now, how do we write a code for it? So what's the core logic here? First, whenever you have the values x and y, all you have to do is first figure out the answer for this y applications, and the remaining cells after filling these y applications in the screen, you should fill those x. And when you don't have the enough number of cells in the screen, only then you have to consider the additional screens, right? Okay. Like if you have maybe 20 comma 1, and the number of cells in each screen is just 15, right? For sure, you can fill all 4 cells in here. The remaining cells are 11 now. And you have to fill all these 20 cells in 11. Of course, you cannot do that. So, you'll fill all 11 from here so that 9 are remaining. And for these 9 cells, you have to consider another screen having the same dimensions, of course, which is of 5 cross 3. So the overall answer would be then 2. Okay, I hope you got the solution right. First, what we're supposed to do? Let us just consider our answer is equal to the CL value of y by 2. The CL value of y by 2. Right? Okay. Or we better write it this way. The CL value of y by 2. Okay. Then, how will you know the remaining cells after filling these y applications? Simply, we can say the remaining cells is equal to answer into 15, okay, minus the number of cells that you have used, which is simply y into 4, right? This will give us the exact remaining cells that are left from the screens. Now, as mentioned, if your x is greater than the remaining cells, only then you have to make use of extra screens, right? Okay. If this is the case, what you're supposed to do? What you're supposed to do? Out of all the cells, first you'll fill out all the x minus remaining in the screens. Now the additional x cells are this. For this, you can simply say that answer plus equal to the CL value of current by 15. That's it. Okay. Those many number of additional screens you're going to make use, right? That's it. So simply just print the answer over here. I hope you understood the logic and code part. Okay. Now we'll code it up. Well, let's code it up. First, we have to read the test cases. Now we have to read x comma y. Now we should just assume that our answer equal to math.cell of y by 2. Of course, to use cell, we must import math. We just import our math. Now, what's the next thing? Calculate the remaining cells from all the screens. So I'll just say answer in 15 maybe. And next, the number of cells occupied, y into 4 as discussed. Next, if my x is greater than remaining cells, then what will I do? I'll just calculate the remaining, which are x minus remaining cells. Now, our answer will be updated with answer plus. That's it. That's it. Now, you will just have to print the answer. And the sample test cases, yeah, I think we didn't copy the test cases. Okay, we'll do that. Yeah, we'll run the code. Okay, we'll just compare the output. 112211 0. Yeah, we'll just submit the same code. Submit. Okay, submit. Yeah, it worked. Okay, so this is all about the question one. I expect you people as well to solve the same problem if you didn't solve this in the contest. Okay, we'll move to the next question then. Now we'll look at the second one, symmetric encoding. So Polycarp has a string S which consists of lowercase Latin letters. He encodes the string using the following algorithm. First, he constructs a new auxiliary string R, which consists of all distinct letters of the string S written in alphabetical order. Okay. So what he'll do is, whenever you are given an input S, all we have to do is just pick the distinct letters of it, and that too in alphabetical order. Okay, cool. Then the encoding happens as follows. Each character in the string S is replaced by its symmetric character from the string R. The first character of the string R will be replaced by the last, the second by the second from the end, and so on. Okay. So at the end, for example, encoding the string S happens as follows. After considering, so this is our string S. So when you consider all the distinct letters in alphabetical order, which is of course in a sorted order, we'll get this R. And after that, this S is being replaced with this C. Okay, here it is mentioned. And this D will be replaced with R, and then E will be replaced with O, and F will be replaced by itself. Now, for the given input string S, CodeForces, so we're just considering the input string. So this C should be replaced with S, right? So okay, we'll just replace it with S. Now, the next letter is O. So this O should be replaced with E. So we have to print E. Then the next character is D. This D should be replaced with R. So we'll print R. And next E should be replaced with O. And similarly for all the characters, F with itself, O, E, next D, next S, next O, and then C, which is our resultant string. We'll just compare this with the resultant. Okay, so yeah, this is the resultant string. Yeah, it looks more like an implementation based question. This is even better than the first one, we can say. So you can also look at the constraints t equal to 10 power 4, n equal to 10 power 2 into 10 power 5, and it is guaranteed that sum of values of n over all the test cases in the test does not exceed 2 into 10 power 5. Okay. Yeah, there are no edge cases for this question as well. The only thing you have to worry is only about the mapping part. Mapping part, you should figure out a logic, you should figure out a way in such a way that the mapping is done in a simplest way possible. Okay. Now, if I say mapping a character with another character, what do you remember? Okay. Just put your thoughts on the paper, pause the video, try out a solution, and code it up. Okay. After that, we'll discuss the approach. What's the simple implementation for this? If this is your string S, you have to consider the first auxiliary R and then sort it. So we can simply use a hash set, and for all the elements in a hash set, we can sort it. Or is there any other alternative? Yes, we can make use of a count array. So with the help of count array, you'll populate S and store in the count array, so that it will keep track of the duplicate elements as well. Okay. So how exactly you're going to do that? You'll just traverse for int I equal to 0, I less than string length, I plus plus. If your count of ASCII value, which is S of I minus 97, is equal to 0, is only when you have to consider it to a R, right? Or we can say that we are just storing it over here. You can simply write count of S of I, my bad, this should be I, not 1, S of I minus 97 plus plus. So after this, you have to consider some temporary string. Let's say this is your temporary string, or we just write the exact syntax for the reference. Okay. Now we'll consider an empty string temp. Now we'll just iterate through the count array. In fact, we'll iterate till 25th index is enough. So if your count of I is not equal to 0, then what you'll do? Simply you'll add it to the temporary string, which is more like something like character of I plus the ASCII value, which is 97. Okay. Now we have to map the characters of this string in such a way that the first element of temp is being mapped to the last element of temp, and second element of temp is being mapped to the second last element of temp, and so on. How we discussed in the explanation part. Okay. Now, how will you map that? If you are able to map that, the solution is done. So how will you map? How will you map now? First, we'll consider a hash map. So what exactly you're going to store in a hash map? You're going to store the characters. You're going to store the characters. I'm just writing a pseudo code, okay? Not the exact code. Okay, we're storing the characters in the hash map. Now simply for int I equal to 0, I less than length of temp, as we are using temp dot length, temp dot length I plus plus, and now you'll simply map it in this way. HM of temp of I is equal to simply temp of some length of temp, or temp dot length minus okay, so temp dot length minus I minus 1. So this is how you map it in the hash map. Now you just need to compute the answer. Okay, so how will you print the answer? Simply for int I equal to 0, I less than s dot length, which is nothing but the input, I plus plus. What you'll do, you'll simply print the mapped character of the current s of I, right? So where do you have the mapped character of s of I? Simply you'll hit the hash map for it. So simply hash map of s of I, that's it. As you want the entire string, you'll just say you're going to print the entire sequence in the same line. Okay. I hope the code is clear. Code it up, guys. So this is the reference for the entire code that we have written. I hope the code is clear. Okay, we'll move on. First, we'll move about the test cases simply. Now we'll read the length of string. Now we'll read the string. Now we'll populate and store it in the count array. And then we'll consider some temporary string. Now for element in as this is nothing but a for each loop. If my count of the corresponding element frequency is 0, then I'll store it in the count array. So just to store the frequency, I'm writing it like this, and then find range of the size of count array, which is 26. Now, if the particular character exists, which is like for count of I not equal to 0, then I'll consider the character to the temporary, right? Which is character of I plus 97. Okay. Now, we'll assume that something like x is the length of our temporary string. Now, we'll consider the mapping part. We'll consider the hash map for I in range of x. Simply, hash map of temp of x should be mapped to temp of x minus I minus 1. That's it. Now we'll just consider some answer variables, and now we'll iterate over the input string, and we'll map the current element to the hash map of element. That's it. We'll just print the string. Okay, I think the code is fine. It's running. Okay, it gave us some errors. Okay, not X, right? It should be I. Okay, next. Yeah, we are good to go. We'll submit this. Okay, we are good to go now. Okay, accept. That's it for question 2, guys. We'll move to the next question. Here we go with the third question. Polycarp was given an array A of n integers. He really liked triples of numbers. So for each A, 1 less than or equal to j less than or equal to n minus 2, he wrote down a triple of elements aj, aj plus 1, aj plus 2. Polycarp considers a pair of triplets B and C beautiful if they differ in exactly one position, that is, one of the following conditions is satisfied. Okay, B1 not equal to C1, B2 equal to C2, and B3 equal to C3. Or B1 equal to C1 and B2 not equal to C2 and B3 equal to C3. Or B1 equal to C1 and B2 equal to C2 and B3 not equal to C3. Basically, um, for any two triples that I consider, only two elements must be equal, except, of course, the third one should be unequal. Okay. Overall, you just have to find the number of beautiful pairs of triples among the written triples. AJ, AJ plus 1, AJ plus 2. Okay. Perfect. Input T is 10 power 4, 2 into N is 2 into 10 power 5. A of I is 10 power 6. Okay. Note that answer may not fit into 32-bit data types. Okay. Then we must use long. Okay. So I'll just give you a rough picture of this problem statement, guys. For example, if you have this array 3, 2, 2, 2, and 3, all you have to do is just pick all the triples. Let's say this is a triple. Having the elements 3 to 2 is a triple. Okay. Next, 2 to 2 is another triple. 2 to 3 is another triple. Okay. I'm just rewriting it over here. 3 to 2 is one triple. 2 to 2 is another triple. 2 to 3 is another triple. All you have to do is just count the number of triples. Okay. So this and this can be a triple. The reason is B2 equal to C2, B3 equal to C3, but B1 not equal to C1. For that reason, I can consider as of now my answer is 1. Okay, I'll compare this with this triple. What do I observe? This 3 not matching, 2 not matching. So it doesn't follow the condition where any two triples maintaining. In fact, you should consider the indices. Or let me just derive that statement from here. Only when you maintain this condition, if any of it is true, then we can consider it as a good triple. Then we'll count it to the answer. Okay, as it's not satisfying this case, we won't consider this as a triple. Okay, so what else, what else triples we can consider? We can consider even these two as well, right? So if we consider these two are same but not this. Okay, which is as mentioned, which is as expected. So we can consider this as a second triple, which is 2. That's it. We have checked all the possibilities. So our answer is 2, which is as expected. Okay. Now, now we'll consider, let's say, this test case where it is 2, 1, 1, 1, 1, 1. Add another 6, right? Yeah, 6. Now, what are all the triples here? 211 is a triple. 111 is a triple. This 111 is a triple. This 111 is also another triple. Okay. Now we'll just rewrite all the triples here, which are 211, next 111, next 111, next 111. These are all the possible triples. Now we can consider this pair as a good triple. The reason is 1 and 1 are equal, but this 2 and 1 are not equal. So we can consider this as a triple. Next, this, the same one. So we can again consider this to a triple. Next, the same case. Even this we can consider this as a triple. Okay. Now here comes the main thing. Can we not consider these two as a good triple pair? Can we or can we not? We should not. We should not. The reason is all three as well shouldn't be equal. All three as well shouldn't be equal. Only any two consecutive elements of triple must match. Not all the elements of a triple. For that reason, we cannot consider these two. For the same reason, we cannot consider these two as well. For the same reason, we cannot consider these two triples as well. Okay, so answer will remain 3. So what's a brute force implementation? What's a brute force implementation? Just you have to generate all the windows which is of size 3, and then for each window, for this window, go and check for all the triples. Again, once you're done, go to the next window, do the same thing for all the remaining triples. Again, go to the next triple, do the same thing for all elements. So what would be the time complexity? It is order of n square, t into n square, but as per the test cases, t is 10 power 4 and n is 10 power 5. And of course, here as they mentioned, as they won't exceed 2 into 10 power 5, we can say that n is 10 power 5. Okay, in that case, in that scenario, n square logic won't work for sure. So how will you optimize this? How will you optimize? Just observe what's taking time over here and how will you optimize it. In our brute force logic, what exactly is taking time? What do you observe from here? Whenever you are at some ith triple, you should know the number of occurrences of the triple in the previous instances. If you are able to know that, if you can somehow store the answer, for that, your task is done. Right? Figure out a way to implement that. Put your thoughts on the paper. Okay, figure it out. So did you figure out how to optimize the brute force relation? I gave you a hint, right? How to optimize the brute force relation. You just have to store some data in some data structure, which when you encounter the current triple, it should give you some answer. So which data structure is a perfect fit for the current scenario? A simple hash map is the best fit. Okay, I'll just explain you how. Okay, I'll just explain you how. So what exactly will I do? First, while generating all the triples. Okay, something like this. Hmm. Now, while generating all the triples, which generally all the windows, which is of size 3. Okay, now let's assume I'll place some, let's say a hash map, maybe, yeah, hash map HM1, and I'm going to store a pair array of I and array of I plus 1 in it. Okay, if it's even better if you consider some default dictionary so that I can directly write plus 1. And similarly, I can rewrite the same thing for some other hash map where I am going to place array of I plus 1, comma, array of I plus 2. Okay, next, the third hash map, what you are going to store? Array of I, comma, array of I plus 2. Okay, this is the third pair that you are going to store. And internally, the current triple is 10, which is from array of I plus 1, array of I plus 2. What we'll simply do is for the answer, we'll just add the resultant of this and this and this. How is it? First, I'll simply write answer place equal to hm1 of array of I, comma, array of I plus 1 plus hash map 2 of array of I plus 1 and array of I plus 2 plus from the third hash map I'll pick array of I plus 2 comma I plus 0, which is simply I, and I plus 2. So I've considered all the triples, but I have to cancel out whichever I'm having the duplicate triples, just like 111, 111, 111. I have to cancel out all these triples, right? To do that, what will I do? I'll again consider some tuple, or just for storing the current triple. So I'll simply store, hash map using the tuples, using HM4, HM5, HM6. So whenever you have that tuple, what will you do? From this entire answer, what will you subtract? HM4 of the tuple minus HM5 of the tuple minus HM6 of the tuple. That's it. Okay, we'll just code it up. As mentioned that we are using a default dictionary instead of hash map. We'll just import the same from collections. We'll import default dictionary. Now we'll just read the test cases for in range of int of input. Now we'll read the length of array, and now we'll read the array elements in this way. List of map of int comma input dot split function. Now we'll consider hm1 as a default default dictionary. Okay. Now, which is of size, of course, which generally holds the data integer. We have to do this for hm2 as well as hm3 as well as hm4, 5, 6, 3, 4, 5, 6. Okay. And you have to initialize all these with a default dictionary. 2, 3, 4, 5, 6. Okay, we're done with the initialization part for those default dictionaries. We'll assume that answer is 0. As it is Python, it's not necessary to convert into long all these data type issues, right? If you are using Java or CPP or C or any other programming language, make sure you are using long. Okay. Now we just have to iterate and check for all the windows, which is n minus 2. Now hm1 of the pair array of I and array of I plus 1. This is the pair that I'm going to store, right? Okay. And for this, I'll simply write plus equal to 1. And I'll just copy this, paste, copy, paste. And this is for hm2 and this is for hm3. And this should be I plus 1 and this should be I plus 2. And coming for here, this should be I and this should be I plus 2. Okay, so we are done storing all the triples in a hash map. Now we should consider some tuple. Let's say we have a array which generally holds array of array of I plus 1, array of I plus 2. Okay, now this is the array. For this, we have to create the tuple, right? Simply. So hm4 of this tuple for this temporary array plus equal to 1. We'll just copy this, paste, paste, and now this is for fifth hash map and this is for sixth hash map. Now we just have to update our answer accordingly. So answer plus equal to, as discussed, hash map of this. I'm just copying it and pasting it over here. Minus, you have to do something. What is it? hm4 of tuple of 10. That's what you're supposed to do, right? And same for the remaining 3 hash maps, you have to do the same thing. I'll just do Control C, Control V, and now just update it accordingly, which gives I plus 1, I plus 2 here, and then here 5, 6, I plus 2, and here hm3. That's it. And at the end, we'll just print the answer. Okay, we'll just run the code and check the verdict. Okay, it's working fine. We'll just copy the code, we'll submit it over here. Running on test case 9. test case 11. Test case 17, 18, okay, 20, okay. Yeah, that's it. Done. Make a note of it. So that's it for the video, guys. If you found the explanations helpful and enjoyed the problems, please consider subscribing, liking, and sharing the questions and video solutions with your friends. Thank you.